Hello everyone. In this lecture I am going to discuss about residues. So what is mean by residue? If z equal to a is an isolated singular point of f of z about z equal to a, if f of z equal to summation varies from 0 to infinity a n z minus a whole power n plus summation n varies from 1 to infinity b n by z minus a whole power n. The coefficient of b of 1 by z minus a is called residue of f of z at a point z equal to e. We are having two important formulas for finding residues. These two are very important. If z equal to a is a simple pole, which means pole of order 1 means we must use this formula. So more than 1 means we must go to the second category. Yeah. Simple formula is residue of z equal to a f of z equal to limit z tends to a z minus a into f of z. This is the formula for simple pole for finding the residue. The second category, so pole of order more than 1 means we must use this second formula. If z equal to a is a pole of order n, then residue of z equal to a f of z equal to 1 by n minus 1 factorial limit z tends to a d power n minus 1 by d z power n minus 1 into z minus a whole power n into f of z. This is the formula for more than one order. Okay. Now we are going to see some some example problems under residues. The first one is find the residue of the function f of z equal to 4 by z cube into z minus 2 at a simple pole. They are not asking to find out all pole residue values. In particularly, they are mentioning that we need to find out residue for a simple pole. Look at the denominator, two terms are there. So therefore definitely we will have two poles. In z power 3, the pole is z equal to 0. Because when I am replacing z equal to 0, I will get 1 by 0. That makes the denominator into 0. So therefore z equal to 0 is a one pole. But the order of this z equal to 0 is 3. So therefore they are asking to find out simple pole residue value. This is not a simple pole. Come to the second category. Z minus 2. So therefore here 2 is the pole, but order is 1. So we must go with this alone. So here z equal to 2 is a simple pole. Residue of simple pole formula is residue of z tends to a f of z equal to limit z tends to a z minus a into f of z. Here a is equal to 2 and n is equal to, of course here there is no n because simple pole. So residue of z tends to 2 f of z equal to limit z tends to 2 z minus 2 into f of z is the given function. So after that z minus 2 getting cancelled. We may have 4 by z cube. Replace z tends to 2 here. 4 by 2 power 3 value is 8. 4 by 8 is 1 by 2. So this is the simple pole value of the given function f of z. Come to the second problem. Calculate the residue of f of z equal to e power 2ez by z plus 1 the whole square at its poles. So in this particular problem, in the denominator, I am having only one factor. Definitely I will get only one pole. So z equal to minus 1 is the pole. Z equal to minus 1 is the pole, but order is 2. So we must use the second formula. Residue of z tends to a f of z equal to 1 by n minus 1 factorial limit z tends to a d power n minus 1 by d z power n minus 1 into z minus a whole power n into f of z. Here we must know what is a and what is n. N is the order, that is 2. Say z equal to a is the pole. Pole is a minus 1. So z equal to minus 1 is a pole of order 2. Now I am replacing a as well as n in this general formula. Residue of z tends to minus 1 f of z equal to 1 by 2 minus 1 factorial is 1 factorial. Limit z tends to minus 1 d power n minus 1. 2 minus 1 value is 1. D z power 1. Z minus a. So therefore, minus 1 is, minus of minus 1 is plus, z plus 1 the whole square. F of z function is e power 2z by z plus 1 the whole square. Here also z plus 1 the whole square, z plus 1 the whole square getting cancelled. I will get alone e power 2z. D by dz of e power 2z. Differentiation value of e power 2z is 2 times of e power 2z, because the general formula differentiation value of e power ax is a into e power ax. In place of a, I am having 2. So therefore, d by dz of e power 2z is 2 times of e power 2z. So next, I am replacing z value in this particular function. So in place of z minus 1, it will give 2 times of e power minus 2. So this is the residue of the given function f of z. So let us move the third category. Find the residue of f of z equal to z square by z minus 1 the whole square into z plus 2 at each poles. We need to find out a residue value of all the poles. So therefore, here we are having 2 poles. One is 1, another one is minus 2. In the first term, I am getting the pole is 1, because 1 minus 1 is 0. So therefore, 1 is the pole, but the order is 2. In the second term, I need to replace minus 2 for making of denominator 0. So therefore, minus 2 is the pole, order is 1. So take that 2 poles, z equal to 1 is a pole of order 2 and z equal to minus 2 is a pole of order 1. I am going to find out residue for 1 by 1. So first I am going to find z equal to 1. Here order is 2. So therefore we need to use the second category problem. So second category formula. Second formula is limit z tends to a f of z equal to 1 by n minus 1 factorial. Limit z tends to a d power n minus 1 by dz power n minus 1 z minus 1 whole power n into f of z. Here n is equal to 2. Replace it here. Limit residue of z tends to 1 f of z, because here z equal to 1, a is equal to 1, right? So residue of z tends to 1 f of z equal to 1 by 2 minus 1 is 1. Limit z tends to 1, d power 2 minus 1 by dz power 2 minus 1, both are power getting 1. So z minus 1 power n is 2 into f of z is given function. Now z minus 1 the whole square, z minus 1 the whole square getting cancelled. The remaining terms are z square by z plus 2. So next I need to differentiate this z square by z plus 2 with respect to z. So both the numerator and denominator containing z, we need to apply the quotient rule. So first u by v means v into du minus u into dv. You just keep z plus 2, differentiate z square, that gives 2z minus z square into z plus 2 differentiation value is 1 by v square, the denominator square term value. So now I am direct away replacing the points z equal to 1 in this particular step. I will get 1 plus 2 is 3, 2 into 1 is 2, minus of 1 square is 1 by 1 plus 2 is 3 square. So therefore 5 by 9 is the answer for z equal to 1, pole of order 2. Next, I go with second point, z equal to minus 2. Here the order is 1, so we may use the simple pole formula, that is residue of z tends to a f of z equal to limit z tends to a z minus a into f of z. Here a is equal to minus 2, order n is equal to 1. So limit z tends to minus 2 f of z equal to limit z tends to minus 2 z plus 2 into f of z value z square by z minus 1 the whole square into z plus 2. Z plus 2 getting cancelled. Next directly I am replacing the point. I will get minus 2 the whole square is 4 and minus 2 minus 1 is minus 3. Minus 3 the whole square is 9. So this is the residue value of the corresponding poles. So therefore in this video we learnt how to find the residue value of each poles of the given function. In the next we are going to discuss about Cauchy's residue theorem. So this is very important category in this complex integration unit. Okay guys, thank you guys.